All right, everybody, so today we're going to pick up where we left off last time. And the last thing we were working on in classes was we had written and started writing the teacher class. If we take a look at where our code is, we now have this class, the original class that we started the year with, the person class, the student class, the Husky class, and the teacher class. And all of those classes have started coming together. So from our example where we started back making person objects, student objects, and then eventually Husky objects, we started writing the person class, the student class, the Husky class, and now the teacher class. Okay, so picking up where we left off, we're now going to write a method for the teacher class called the teach method. So public void teach, because that's what teachers do. Okay, and we'll define what it is for a teacher to teach. Now remember, a teacher has a collection or an array of students. So what we're going to do is we're going to loop through that array. So we're going to use a for loop and go to students.length to travel through the entire array of students. And as we go into each students, we're going to have them study. We're going to say students spot I dot study. Whoops, let me try that again. Students spot I dot study. Whoops, wrong one. Study. So study is a method within the student class that we defined as a way to raise your average. So now the teacher will do that. The problem is, what if I don't have all 100 students in my array? So to avoid an error here, we're going to also build in a little check. If students spot I is not equal to null, which is what would be in the array if there was no student there, then I will have them study. So the if statement just avoids that problem. Okay? All right, so let's put this to the test. Let's make a teacher. Teacher equals new teacher. Our constructor requires us to give it a name, an age, and a gender. So let's do that. Let's start with the name. So this teacher's name will be Mr. Walks. This teacher's age will be 47, and Ismail, yes. Okay, now I can assign students to this teacher. So teacher dot students, whoops, spot 0 equals, so the first student I'm going to assign is the student I created back in our example, just called student. That's a student. So I'm going to say you go at spot 0. Now I can assign another student. For example, Marty can be assigned. So I'm going to say, repeat this, switch this to Marty, and put that at spot 1. So student at spot 0, Marty at spot 1. And those are all the students I made, but wait a minute, no, that's not true, because a Husky is a student. So can I add the Husky to the array at spot 2? The answer, of course, is yes. So I'm going to add Husky to spot 2. So I have spot 0, 1, and 2 filled with 3 students. Then I'm going to take that teacher and have them teach. So I call upon that method. That method should run through this array and have each student study a little bit. So we just had our Husky talk. And when the Husky talked, it outputted its average. Let's have our Husky talk again after they've been taught. And let's see how that plays out. So before I taught the Husky, their average was 3.8 with 0, 0, 0. But after I taught them, their average is 3.9. Because the teacher method, teach, has the students all study. Actually, why don't we have the students talk? Students spot I dot talk, which will avoid the need for me to do this right here. Play it again. Now you'll notice Jane Doe, Marty McFly, and Havoc Husky are all talking. And their average, so here's Marty McFly. His average is 2.9. The last time we heard from Marty McFly up here, it was 2.8. So you can see that's getting raised. Same with Jane Doe. Her average was 0.0, but now it's 0.1. So the teacher is raising the student's average through the method. Let's add one more method to our teacher class. Public void talk. This method, as you recall, is an overload method because a teacher is a person and we already have a talk method here. By creating this talk method, we are overriding, notice the thing there, the person class. The person class now recognizes that its method is being overridden. All right, so let's make the teacher talk. First, we'll do a super dot talk. We'll put out all the person information. And then we'll output that I have students dot length. So I'm going to output that. I have that many students. So when a teacher talks, that's what they say. Except don't misspell it. And so then ultimately then I can go back here and have my teacher talk as well. So let's just add that to the output. I have 100 students. Okay? I am Mr. Walks, etc. So overloading, okay, actually, how about a tab? I am a teacher. And I have this many students, which is outputted with that. Okay? All right, the final concept I want to teach you in this unit in classes is an important one. It's the concept of polymorphism. This concept will be expanded on in way more detail in the grade 12 computer science class. It's in a lot of ways the most important concept to finish the grade 11 computer science class on. So if we look at the word polymorphism, it comes from a Greek word, poly, which means many, and the word morph, which is to shape, to form, or to change. We hear the word poly or the prefix poly in words like polygon or polynomial. Again, it means many. Morph as well we hear in lots of different things. It actually is a biological term, polymorphism, which is an organism that has more than one form or morph, like for example a moth, a butterfly, etc. So this has a similar meaning in computer science. The most common use of polymorphism in object-oriented programming is when a parent class is being used to refer to child classes within things like method calls. Obviously, this is a big example, but let's see how we can apply this to our example. So what I want you to do is I want you to make our final class in our project a new Java class, and this class will be called the meeting, M-E-E-T-I-N-G. So this will be our meeting class. Let me just clean it up. Strip it down, and let's take a look at our meeting class here. Okay, so our meeting will be similar to our teacher class. It's going to hold an array. This time let's encapsulate it. Let's make it private. It'll be a person array called the members of the meeting. We will also keep a private integer for the index number, which, as we know, we use with arrays, like what index number are we at? Let's start building up our constructor. So meeting will be our constructor for this class. So just as a recall, constructors are special methods that are called when the class is instantiated into an object. We're going to set these two properties to their starting values. So members will be an array, a new person array, and let's set the number of people who can attend this meeting at 500 people. So 500 people are the members of this meeting. And of course, the index number, we start at 0. Arrays start their indexes at 0. That's our basic meeting. Okay, so let's go to our testing class and let's set up for this. So let's create a meeting. Meeting equals new meeting. That instantiates an object of type meeting. The object is called meeting. Okay? So now when it calls the constructor right here, it sets those two properties, members and index, to their starting positions. All right, let's add a method to this class. If we're having a meeting, let's make a method or an action to add a person to this meeting. We're going to add, and we're going to give it a parameter, a person called person. So this particular person object will be added to the meeting, which means we're going to have to put them into the array. All right, so let's do that. Members, that's our array, at spot index, which starts at 0, perfect, equals this person. Done. But if I call this method again, index stays at 0. So if I want to move to the next spot, I'm going to set index up by 1. So I'm going to increase index by 1. This will work every time until I reach the end of the array. So let's drop an error check in as well. If the index is greater than or equal to 500, I've reached the end. I'm going to set the index back to 0 to start over again. That's a simple version of the if statement that just checks it. I omitted the curly brackets. I certainly could have put them in there, something like that if I wanted to. Or more that's more the C# style, or maybe the Java style. Or like I said, I don't need, because it's just one line, I don't need any brackets. And if I want, I can even move it up like this, which is what I originally wrote. I just think that saves a little space. All right, so let's test that. Let's add a person to our meeting. Meeting.add. So I can add my first person, which was the first one we created up here, person. Okay? But I think I'm going to want to add multiple persons to my meeting, so more than just one. So if I look through here, the next person I created was Bella. So I'm going to take Bella and add them to the meeting. The next person I created was Jacob. So I'm going to take Jacob and add them to the meeting. The next person, oh, that was all the persons I created. I created a student. But here's the concept of polymorphism. A student is a person. So through a polymorphic, if I use that term, sort of example here, a student becomes or morphs into a person for the purposes of joining the meeting. So student is a person, so I can add them to the meeting. Oh, that must mean I can add Marty. Marty's a student, which is a person. And finally, I can also add the Husky to the meeting. A Husky is a student, and a student is a person. And, oh, I can add the teacher as well. So let me add this teacher to the meeting. So all of these are of type person, so that's where the polymorphism is kicking in. Let's do one last one, meeting.add. I don't really have any other people to add, so I'm going to create a new person right here inside the add method. This is what's known as an anonymous object. It doesn't actually have a name. It's just the new person being created right there. So this will go to spot 0, spot 1, 2, 3, 4, 5, 6, and 7. I will have a total of 8 people at the meeting, even though it can hold 500. All right, let's add one more method to the meeting. Public void. What do you do with a meeting? Well, you hold the meeting. So let's have a hold method here. Okay, so I'm going to do an output and say meeting begins. Okay, but then I'm going to add a little more to that. Okay, so the meeting begins. Then what I'm going to do is I'm going to once again run a for loop through members, that's our array, dot length, which we know to be 500 strong. If, okay, members spot I is not equal to null, you know, I think I'm going to do this a different way. This time I'm tracking index, and index keeps changing as I add people. So rather than do this, what if I just put index there? That'll stop the loop at the spot where the last person was added. And then I'll have the members at spot I dot talk at the meeting. So each member will talk at the meeting when I hold the meeting. So let's take the meeting and hold the meeting. And let's see what happens. The meeting begins, and every single person at that meeting, all the way up to the anonymous person that we created, talks at the meeting. Okay, in the slide notes for this particular unit, all this stuff on polymorphism is covered. The code for the meeting is there. The code for the methods are there. The testing code or a version of testing code is there. Okay, and then the output that it generates is produced. Finally, this concept will be expanded on, as I said, in the grade 12 computer science course or the IB computer science course if you want to learn more about the concept of classes. Thanks for listening. Subscribe if you'd like. Have a great day.